Alright, so this is the third exercise now in the diagram window course. What we've learned since the last exercise were two things. We learned how to put ease plots onto a diagram window, and we also learned how we can build drop-down menus, so string lists, and map different equations to different selections in the string list. And so this exercise will force you to use both of those skills. So here's the exercise. It's a cycle model. So on the left you see what's called a partial cooling cycle for a supercritical CO2 power system. And then on the right you see the recompression cycle. And the recompression cycle is actually simpler than the partial cooling cycle. You can see to make the recompression cycle, all you do is you remove the precompressor and you remove cooler 1. And so what you need to do in this exercise is develop a GUI that allows the user to control the partial cooling cycle simulation, and also allows the user to switch between a full partial cooling cycle and the recompression cycle. If you look, you'll see that the partial cooling cycle has already been built, so you don't necessarily have to start from scratch and rebuild it. It's the subject of one of the YouTube videos, and we'll have that in the link below as one of the files that you can download. So you can start with that, and you don't have to reinvent the wheel there. Also in the file that you can download are two schematics, so two JPEG files, one corresponding to the image on the left and then the other to the one on the right. And so you can start with those things, and what you need to do then is go ahead and build a diagram window that allows the user to select from a drop-down menu either the partial cooling cycle or the recompression cycle. And the diagram window should have a schematic on it, and that schematic should adjust itself depending on what the selection is. There's a TS diagram of the cycle that needs to be on the diagram window as well. You might want to look into the $PropertyPlot and the $OverlayPlot directives in order to accomplish that. And yeah, if you look at it, you can see that it's going to take a little bit of logic and thinking to do this. One thing you should realize is that if you want to remove the pre-compressor and cooler 1, you're going to actually have to change some of the equations in the actual cycle model based on what the selection is, right? So there's going to be some equations that will feed into that equation list following the different selections. But yeah, give that some thought, maybe give it a try, and when you're either done or you're ready to see how I did it, come back and we'll go through how you would accomplish this exercise. Okay, so let's go ahead and start. This is the ease file that I'm going to start with. This is with just a little bit of modification, the ease file that resulted from the cycle modeling video that we did, in which we modeled a partial cooling cycle. So this is essentially what we ended with. The only difference is that rather than using the heat exchanger 5 component model, I switched those to the heat exchanger 2 component model. So both recuperators are modeled now with a simpler model that works in the region that we're going to stick with, because the pinch point happens at the ends of the recuperator. But because it's simpler, it's also just a lot faster to run, which in a video like this makes things a lot easier to watch. So that's the basic difference. If you go to the diagram window now, so let's go to the diagram window, you'll see it's kind of a blank slate here. So we have to get started with developing a GUI for this simulation, and then actually having the GUI modify itself based on whether it's a partial cooling or a recompression cycle. So there's kind of so much to do here that it's hard to know even where to start. So I think where I'm going to start is having a GUI for the partial cooling model. Get that going, and then start thinking about how we can modify things to deal with the recompression cycle. So let's see. The first thing I'm going to do is put a schematic on here. So let's see, I'm going to use a graphics object right here. So down here we talked about how to do that. I'm going to use the partial cooling JPEG. You'll notice that I'm going to have to switch that eventually between the partial cooling and the recompression JPEG, but let's start with that. And just in anticipation of needing to control the schematic, I'm going to name it schematic so I can control the file name using schematic.filename. So we'll hit OK. It's about the right size. It probably won't be about the right size on everybody's different computer, so you might have to adjust the size based on the pixels per inch of your monitor, but for my monitor it looks pretty good. I think I'll go ahead and add a calculate button as well up here, and then I'll start thinking about what do I want to input. So if I go back to the equations window, you can see that I have a tab that controls all of the operating conditions. So I think all these operating conditions I'm going to have as input. I don't think I'll bother putting the component performance parameters in there, but we will put all of these guys in there. So yeah, let's go ahead and do that. Once I put those operating conditions onto the diagram window, then of course I'll no longer need the equations that are in the operating conditions tab. So I think I'm just going to take those out right now, and I'll go here and I'll just start putting in different operating conditions. So let's see, I want to be able to specify the hot temperature, so that's TH, which I guess is this here. I will put it in its alternate units, which are Celsius. So that I guess got shoved over here underneath the button. I'll put it up here. Probably the same thing for TC. So let's find TC. Also alternate units. So we'll put this down here. What else? The move that over a little bit. Probably the fraction of the flow that is diverted through the recompressor. So that's called F. We'll put that right here. I think that's where that should go. We need the pressure ratio for the main compressor and the pressure ratio for the precompressor. So that's PRMC, which I'll shove over here by the main compressor, and then PRPC, which I will well, I overwrit PRMC. I'll put that right here and then put PRMC back on there. Find it there. Over here. Now in the future I'm going to want to be able to hide this, because when I have a recompression cycle, PRPC needs to be set to 1 and the user can't control or change that. So I'm going to go ahead and double click on this and name it. So I think I'll name it PRPC input, and the reason I'm naming it is because then eventually I can hide it, right? All these attributes become available to me, and one of them is hide, and I'll want to hide that one. And I think the only other thing I need is the maximum pressure in the cycle. So let's go ahead and throw that on there. Pmax, I think it's called. P-high, I guess. Also in alternate units, and maybe put that right there. So yeah, if I put this in development mode and calculate, then you can see that it calculates probably an output that might be useful. Well, there's a bunch of them, but I'm just going to put the efficiency on here. So my output variable will be the efficiency of the cycle, and we'll use the alternate units to get it in there in percent, and I'll put that right up here. Okay, so that works now. Maybe the next thing to work on is actually getting a TS diagram to show up here. And really what I'd like is a TS diagram that has all these state points on it and actually has isobars that correspond to the actual pressures associated with the cycle. And you can do that pretty easily with the directive called the $PropertyPlot directive, and then another one called the $OverlayPlot directive. So let's go back to the equations window, and then down here at the bottom I'm going to put a $PropertyPlot directive. And if I don't know how to do directives or how to do this particular directive, if you go to options and you hit directive info, you get the directive information dialog. And so I want to look at directives that are related to plots. So I'll put plots here, and I want to make a property plot automatically. And so here's some information, probably more information would come from here. And yeah, I think I'm just going to go ahead and copy this. We'll paste it here. So let's see if this works. Paste. And then I'm going to have to go in and change all these parameters. So let's see. Carbon dioxide is the fluid type. The plot type I want is a TS diagram. So I'll put TS here. This is the number of isobars. So I think I really want just 3 isobars, right? And those isobars should correspond to, it looks like P8 is the high pressure. What P6 or 7 is the other pressure, and then P2 is the lowest pressure. So I'm going to go ahead and put those in here. P2, P, let's say 6, and then P8. This is for the number of, in a TS diagram would be the number of isocores. But I don't want to put any isocores on the plot, so I'm going to put 0 and get rid of all of these. I don't think I want to do lines of quality. And then this is the temperature range, so I probably want to go from, let's say, 250 Kelvin up to 500, maybe 900 Kelvin. And I don't think I need to do any of this stuff. And then the only other thing I'm going to do is name the plot. I think I'll name it TS. And before I go ahead and overlay my state points on here, I think I'm going to make sure that this actually works. I put it in development mode, calculate, and if I go to plots now, there's my plot window, and there's only, it looks like there's only 2 plots, 2 pressures shown, but that's because I think the pressure ratio of the pre-cooler is set to 1. So I think I'll just set it to something other than 1 and make sure that 3 isobars are shown. So here we're going to plot, and yeah, my 3 isobars show up nicely there. Okay, so before I put this in the diagram window, I think the other thing I want to do is overlay my state points onto it. So I'll do that with another directive called $overlay. So again, you know, these things have a lot of parameters and it can be hard to know exactly how to fill them in. So the best way is to go to the directive information dialog, go to plots, $overlayPlot, and then again, directive info. And here is sort of the protocol for calling this. I'll just copy this and fill it in. So copy and paste it, and we'll fill it in. So OverlayPlot, I want to overlay onto the plot that I have made with the property plot, so TS. I want to use my arrays table, so that's ARR. The X variable for TS diagram would be S, so S square bracket I. The Y variable is T, so T square bracket I. I think there's 12 states, so 1 to 12. Let's see, I don't want any lines, this is confusing. I want symbols. I think symbol 9 is a square. Again, if you don't know this, you can look it up in the information. I want a big symbol, so maybe my symbol size is, let's make it 6. Red is probably a good color for it. What else? I think I don't want a legend. We'll put it to the right, that makes sense. I don't want error bars. I do want point labels, so this will label my symbols. I definitely don't want to connect the lines first to last. but I definitely want to auto update. So auto update means that every time I run, I will get the latest set of state variables. So yeah, hopefully this works. So again, we'll just go ahead and solve, and we can go look in the plot, and there it is, right? And the nice thing about this is it's automatically generated every time E solves a cycle, so I can get a new plot. One thing I notice here is that my state 1 is kind of cut off, so my T-max on my property plot is probably not quite big enough. Let's make it 950, and that looks a little bit better. Okay, so there's my plot automatically generated. I think I'll save this, go back to my diagram window, and I want it to show up right here, right? So we talked about how to do that in one of the videos. I'll put it in application mode. Here's my add plot access button. So I'm going to click that. I don't want a button. I guess I'd just like to see the plot. So I'm going to click show plot in the diagram window. I don't think I need to name it because it's always going to be the same plot. So I'm just going to go ahead and hit OK. And maybe we'll move it over to here. And yeah, now I have a simulation that when I solve will update all the state points right here. So I don't know, let's make this a bigger pressure ratio of 3, and you should see the isobars change, you should see the state points change. Yeah, sure enough. Okay, so if all I cared about was the partial cooling cycle, I would be done. But now I got to think about how am I going to make this GUI adjust itself if I want to simulate a recompression cycle. So the first thing I'm going to want to probably do is have a drop-down list that lets the user select between those two cycles. So we'll go here, click input variable. I want a new string variable, and I guess the string name should be cycle. Oops, cycle. It's a string, so $. And I won't want to include the variable name, but I do want to constrain this to either be partial cooling or recompression. And hit OK and OK. And yeah, now I can switch between these two things. Of course, nothing happens when I do that, but it's a start. Okay, so I guess I got to start thinking about what I want to have happen when I select these two options. And one thing that I know I want to have happen is I would like the schematic to change. So because I named this graphics object, I can control the graphics file that's displayed by using the .file name attribute of it. So that's the first thing I'll do. I'll edit this string list, and I'll map an equation for partial cooling that is I guess it's schematic file name $ equals, let's see, in this case I want it to be partial cooling cycle.jpg, like that. Oops. And then for the recompression, I'd like schematic file name $ to be the recompression cycle .jpg. And I would like these changes to happen instantaneously when I make the selection, so I'll hit execute when selected. I'll hit OK and OK, and we should maybe test this. So if I hit partial cooling, yeah, you can see the partial cooling schematic is shown. If I hit recompression, the recompression schematic is shown. It doesn't actually change the simulation, so the next thing I got to do is think about how would I change the simulation, basically to remove the precompressor and the cooler. So if I want to remove the precompressor, basically what I need to do is just set the pressure ratio of the precompressor to 1. And I'd also like to hide this input. So maybe that's the next thing to do, is because I named this input. So if I go back and double click on it, you can see I named it PR_PC input. I can hide it, right? So I have a hide attribute here. So I'll go ahead and add another command or equation here. So semicolon, what is it? PR_PC input dot hide. And if it's the partial cooling, then I want this to be false. So false. And then If it's the recompression cycle, I'd like it to be true. I would like it to be hidden, so true, like that. And I'll hit OK and OK, and let's see, develop or application mode, and we'll go to recompression, and you can see the indicator is hid, or the input is hid. I'm sorry. If I go to partial cooling, now I have it. Of course, just because the indicator, the input is hidden, doesn't mean that it's not counted as an equation. So it's still counted as an equation. I just can't no longer change the value of it. So I need to take care of that. And so the way that I'm going to do that is I'm going to go here to my equations window, and right here I need to add another variable, right? So this is let's call this PRPC set, and this PRPC set, I'd like it to either be 1 if I am simulating a recompression cycle, or I'd like it to be the value of PRPC that I set in the diagram window if I'm simulating a partial cooling cycle. So let's go back here, and we will map another equation to the string list. So edit the string list. The next equation is that PR_PC set is either equal to, let's see, if this is partial cooling, then I want it to be PRPC. If this is the recompression cycle, then PRPC set needs to be equal to 1. And we'll hit OK and OK and put it into application mode. And let's see, if I switch this to recompression, what I should see is that the indicator here will go away, and I will have a pressure ratio of 1. On my cycle. So if I calculate and solve, yeah, now I have, instead of 3 isobars for 3 different pressures, I just have 2, because there's only 2 different pressure levels in my cycle. So that's almost done. Not quite. The last thing I need to do is get rid of also the cooler. So if I go back here to partial cooling cycle, I've now gotten effectively rid of the precompressor for the recompression cycle. I also need to get rid of the cooler. And the way that I would get rid of the cooler is I would just set T4 equal to T5. So basically do no cooling here in cooler 1. So yeah, if I go back and look at the equations window, right now for the partial cooling cycle, T5 is set equal to the value of the temperature you would expect coming out of the cooler. I really don't want this to be here all of the time. Instead, I want to map an equation to the 2 selections, and if it's the partial cooling cycle, then I'll just go ahead and copy this and use this equation, but otherwise T5 needs to be equal to T4. So let's go back to the diagram window, in development mode, and we'll add, I guess, one last equation to this set of equations. So let's see, semicolon, partial cooling, I'm just going to use the one that I copied, but if it's recompression, then T5 needs to be equal to T4. And hit OK. I think I accidentally hit that, so get rid of that and hit OK. And I think at this point I'm basically done, right? Here, if I calculate for the partial cooling cycle, these are all my states. I have a cooler, I have a precompressor. You can tell I have a cooler because I'm cooling from 4 to 5 here. If I go to the recompression cycle and hit calculate, I have now only 2 isobars, which makes sense. And equation states 4, 5, and 6 are now all the same. You can only see 6, but underneath it is 5 and 4. And so basically I don't have a pre-cooler, I don't have a cooler.